of this afternoon session. So thank you for making it back earlier. So the next paper is titled Modeling of Starch Gelatinization Kinetics of Parabolic Rice using Hot Air Fluidized Bed Dry. Please take your seat. You have the preference of sitting there or standing. Either way you can go.
Everyone is picking up and then forward the group is center on the audit of starter and extension can be of power device and is currently using on aggregated drive. First of all, I would like to indicate for carbonized chloride production and all the oxidizer administration. Carbonide is major hydrothermal process and it reduces the molecular chains known as starter ionization. The starter ionization is can affect some quality of carbonized such as companies of carbonized and the starter ionization requires a temperature and temperature. So the process of the produce carbonized as a functional property consists of three steps. The first one is sorting to replace the measure and then steaming to apply heat to the starter ionization. And the last step is drying to reduce the moisture for unsafe storage. Now the modern dry heating quality has been developed and this process can eliminate the steaming process. So the starter ionization will occur in the drying step. Usually carbonide produced by the high amylose, right? So it have a kind of funky texture and it also have a specific smell from the production. These are reasons why the carbonide is popular only in the regions. On the other hand, aromatic rice that categorize one low amylose is widely popular around the world because it has a sweet aroma from the contrast to a sweet calorie and it also has a soft texture So it's interesting to use the variety device for making the power lines because it's another option to for the people who don't like the architecture or traditional power. Spatial organization can affect the variety of varieties, and spatial organization can be of modern writing and practice. Very interesting because it's dependent on the master content and the brain temperature during the writing step, which different from the conventional powering production. So the objective of this study to study the kind of structure organization for writing using analytic writing and determining the quality of collaboration, including character, texture, color, and element from art and structure. In this work, currently, one of the sides was in the experiment and to increase the master content, the candy was sold at 75 degrees Celsius for the bottle and then dried at the touch contact with the drying that showed in the figure one. And the drying functional in this experiment is and measure of 120 and 130 with them of consider and velocity of 4.5 meters per second. And for determining the writing scientific, the happy watt will remove the writing shadow and remove it patterns within the time. And the temperature of the brain was measured by the infrared thermometer. And next step is the measuring the quality of power. Similar structural organization occur in the brain state, so the hidden mass transfer must be taken according to the analysis of the spatial organizations. The migration of molecule in kernel and the reconduction into the kernel was specified by equation 1 and equation 2. Additionally, the energy loss of the structure organization is considered in terms of heat. The change in gelatin star was described by second order reaction that showed in equation 7. X is a degree of unstructured of the signal with the steam and K is a rate constant that is a function of pressure and temperature. As for the equation A and A, B, and C constant was provided by the optimization using measurement method from minimize the limits at the equation. Now we are on to the result indication. You can see that in the figure 2, higher of drying temperature leading to a higher of mid-end mass transfer and the drying characteristic can be divided into period. First final period and second final period. And the first final period has effective responsibility more than second period. Figure 3 shows you the confidence of university or the of uncertainty style during the various steps. You can see that at the beginning of the writing step, the percent of the is equal to 80% is with the started organization is already occurred in the soaking step around 20%. And you can see that in condition of 120 and 130 degrees Celsius, it can achieve the complete generalization indicate that the university is created zero about 67. But the condition that we have with the Celsius cannot achieve the complete generalization. In terms of prediction, the kinetic model can predict the experiment with risk error about 5 to 7%. You can see in the therefore trade review relate to the master content and the optimization. When generalization is increased, the review will be increased because the start generalization process occur is allowed the kernel space. However, if decrease the master content at below the 30%, the review will be dropped because of the penny export decrease too long. The habit and the stickiness, we can see that the generalization leading to higher in the technique. But in case of stickiness, after the stickiness decreased about 40%, and there is no significant change during we saw a color view provided by Alpine increase with the increase of right time driving temperature. But instar and booster increasing the right time driving temperature. The shape of the color of colors is because of the migration of color pigment during the setting and the Maillard reaction at temperature during the this slide shows the color of color compared to the you can see that the color line color in the light level to the green and it categorized as light color lines. In case of firstly wondering of element, in figure A, we can see that after solving the dimensional to AP value decrease, during the driving there is no significant change. That's because of the driving institution. This is condition. Driving characteristic have two periods, first and second. The first have a higher energy exclusivity than the second period. And the given generalization can be accurately the experiment data with about 5 to 7%. And the star generalization can be directly and increase the happiness of the tolerance. But the stickiness decreases by only the same number of solving but not significant that. As a result, within the stickiness that is a challenge of global management. The best condition is study for making the light is studying to measure of rate and very essential. We could continue our life and the of 64%. However, the concept content should not be reviewed below. The peak was there, and the color of this color is quickly color that one and the initial is so in at 75% maybe can review to the but the right process is not other than fit to it is the value of grounding and to preserve our national however so I would like to say thank you to Dr. Angao and Scholars for recognizing that.
Question to the speaker. Yes, please.
So, this is a general question. Of the rice produced in the country, what percentage of it gets farmed? So, let's say, or other way, take the population. What percentage of people do farm and the
But person Thai people cover. I'm not sure, but the speed of power line will export to the South Africa.
so not in the country?
I think
No.
yes.
So, the mango is right one of the popular. It's right, and that sticky rice from farmers. Yes, no. So variety. So my question was, is the preference by the local people for sticky rice or normal? Or sticky or farmer, normal rice, it's mostly for export.
Sticky and hard one, I would say.
Not the thing.
Sticky rice is a kind of, it's like species rice, which has a very low nitrous content. And it's not hard rice. Hard rice is mostly for export.
In that context, if you look at the population, West Africa, they live in that.
And just for second, like to be intake of parboiled rice will be lower than normal. You know what it's like to be.
Yes, as I know, after Hawaii, that's higher than.
I thought that was what you said.
Okay, any other questions? If not, thank you very much.
So speaker is Mr. Babuya. And he will be talking about the development and application of biodegradable spray coatings impregnated with oil and encapsulated starch and particles that is used to extend shelf life of fruits and vegetables. So, maybe
First of all, good afternoon, everyone. Thanks for joining me today. Myself, Rahul, I am a PhD student at University of Guelph, Canada. And today I am here to present before you. The title of my presentation is already explained by Mr. Chetan. Thank you for that. Before moving forward and explain you about my research, let me quickly give you the background of my study. As the world population is increasing rapidly with a projected population of 10 billion by the year 2050, we need an increase in food production. When we say we need more food to feed such a large, huge population, we say not only food, we need healthy food. and fruits and vegetables are considered a well-balanced diet. However, every year, around 20% of fruits and vegetables are lost due to agricultural diseases. Papaya is one of them. Papaya is a fruit mostly found in tropical and subtropical countries. It is rich in vitamin A and C, and it is rich in many total phenolic compounds. However, it is highly susceptible fungal diseases because it is a climacteric fruit and it has a very fast maturation rate. It has been found that every year more than 50% of papaya fruits are being lost to fungal diseases. And in order to avoid that, farmers are using synthetic pesticides or chemical-based fungicides. However, those chemical-based fungicides are not really environment friendly and does not support the idea of a sustainable future or a sustainable agriculture. Therefore, in order to get a sustainable future and sustainable world, we need something which is from natural sources and which we can use for the future. Therefore, our research group focuses on developing different methods to synthesize nanomaterials and finding different natural fungicides or pesticides to treat different agricultural diseases. In this study, we use Azadirachta indica seed oil, also known as neem oil, for the disease. Neem is a widely popular plant in South Asian countries because it has various pharmaceutical properties, plus it is natural insecticidal properties, it has natural bactericidal as well as fungicidal properties. Now, however, the neem comes with certain disadvantage. It is light sensitive as well as it's volatile. So to protect the properties of the neem, we need something to encapsulate it. So in this study, we are using pea starch as our source to encapsulate the neem oil to protect its properties. The reason behind choosing specifically pea starch is that as the world is growing towards more protein industries, we need protein as an important diet. However, the protein refining industries, once they extract the protein, they left out with the starch. That pea starch from the protein refining industry is considered as a byproduct or waste. It does not find any place in the agri-food sector because of its high amylose content. So as one say, one people trash can be a treasure for another, and we can find really value in one's trash. So our idea was to take that pea starch and make it more valuable so that we can have we can support the sustainable future. Also, the pea starch is not only cheap, it is non-toxic and biodegradable. So the methodology which we follow to develop the nanoparticles which we can use to encapsulate the neem oil was as shown is here. We took the pea starch, we mixed with water and we gelatinized. Gelatinized is basically breaking down the starch for proper encapsulation. Then we added the neem oil into it and then we did homogenization. Homogenization for proper mixing. Then we followed in solvent anti-solvent nanoprecipitation technique. This is an in-house developed method where we sprayed that solution into an anti-solvent, which was ethanol in our case. The moment we sprayed the starch and oil mixture into that anti-solvent, the starch gets supersaturation stage and it precipitates out with encapsulating the oil. Then we followed a method to remove that anti-solvent by centrifugation, and then we freeze-dried our samples to get a final product, which is a powder, but an oil encapsulated powder, so that we can have a better shelf life. If you see on the top right corner, this is a transmission electron microscope image where you can see how the starch was able to encapsulate the oil. Moving forward, when we were synthesizing the method, we realized that the process requires optimization. Therefore, we followed a box bank and optimization technique to optimize the parameters where we take 5 independent variables: initial starch, homogenization, speed and time, sample injection rate, and the rate of solvent and anti-solvent. Whereas on the other side, we have taken 3 dependent variables: encapsulation efficiency, which is the ability of the material, the starch, to encapsulate the oil, then polydispersity index to see how dispersed our nanoparticles were. Are they very small or big, and the mean particle size. These are the optimization results which we obtain at the end, where we saw that we were able to achieve an encapsulation efficiency of more than 80% with a polydispersity of 0.4 and a particle size around 300 nanometers. Now, moving forward, these are the size distribution chart and some more microscopic images where you can see we were able to get all the particles within 1000 nanometers. You can see two peaks at the drying, which might be because of some of the agglomeration during or aggregation during the drying process. Now that we have developed the nanoparticles, we need to see whether it can actually work as a fungicide or not. So we did a small study on papaya fruit. What we did, we redispersed the powder in DI water at a concentration of 21 mg per ml, after which was based on our preliminary study. We have taken papayas of similar shape and size of different similar color, and then we sprayed our nanoparticles on the fruits at 2 ml per liter. And then we did a shelf life study for 10 days at two different temperatures, at 4 degrees and then room temperatures. During that period, we measured the color, the visual, and we measured the total soluble solid pH, antioxidant activities, and total phenolic contents. These are the results from the study, where the first column is the control at room temperature, followed by coated at room temperature, control at 4 degrees, and coated at 4 degrees temperatures. You can see after 5 days, we can see mold and fungus growth at the control compared to all other treatments. And at the end of 10 days, again, the control was completely destroyed compared to the other treated samples. In terms of weight loss and other physicochemical properties, there was not much significant difference between the control and the treated, which signifies that even after spraying our nanoparticles on the fruits, it's not changing any internal characteristics of the fruits. We found that the weight loss gradually decreased over time, which might be because of the moisture loss. And the PSS and the pH got increased, which might be because the fruits got ripened up, become more sweeter, and because of that, the pH and PSS. And the total phenolic content, antioxidant activity, and puncture test. Again, the total phenolic content and antioxidant activity, we saw a gradual decrease or slight decrease, which might be during the ripening process, the fruits might have used up some of the total phenolic components or antioxidant properties or phenolic compounds to ripen. We also did a puncture test to see the firmness, and we saw like it was a gradual increase at the room temperature. However, at control, there was an increase and decrease. The increase might be because of the moisture loss, whereas at the control at 4 degrees, we saw an increase and decrease. Maybe at the end, it becomes quite a little bit fluffy, but it lost some of the firmness. Now, in color, there was again not much significant difference. We saw that the color was almost same. However, for the control, by the end of 10th day, it becomes more grayish, whereas the control which becomes more reddish, and it was not having much greener properties. In conclusion, I would like to say that we were successfully able to encapsulate neem oil in the pea starch, and we were able to successfully get an encapsulation efficiency of 80% with a particle size of 300 nanometers. And we believe that this could have a potential in the agriculture, agri-food sector in the future to see whether it can act as a natural fungicides or not. Some of the future steps which our lab are planning to do, we are trying to find different natural fungicides, different encapsulating materials. And again, we are going to see whether this, after spraying on plants at greenhouse study and field study, how they are affecting the plants. We are going to perform in vitro assays to assess the phytotoxicity of the plants. With this, I would also like to acknowledge our funding partners, University of Guelph, NSERC, and our lab mates and colleagues. These are my references. These are some of my colleagues and my professor and my friends, some of the pictures of past conferences and trips. With this, thanks for your attention. If you have any question, you can ask me.
they can't show the
So papaya, usually people recommend at 4 degrees centigrade for cold storage, or sometimes papaya are transported from one place to another. So they follow a 4 degrees like refrigerated temperatures. So that's why we did we performed the experiments at 4. However, as a common man, if you buy a papaya from market, you have to see whether how it behaves at room temperature. So we compared both, but that the recommended temperature is around 4 degrees centigrade. Yes, that's a nice question. For this study, we just went through the similar size and shapes with visual observations. But there are some ripeness index, which for the other fruits, definitely we are going to follow that ripeness index, and we are going to choose specific, like as close as possible or possible. But for this study, we went with the visual observance and like the weight and the size and length. I hope I answered your question.
See, I'm not sure what I'm saying. Neem oil is something non-edible.
Neem oil is edible. It's been used in traditional medicines for like decades, and even in many households in India, they eat neem oil like it's edible. It's not. It's considered from the seed. Yes, neem seed oil.
Is also for mosquito repellent.
Yes, it can act as an insect repellent, mosquito repellent. However, we can also eat sometimes like neem oil, like people use in medicines. You can drink that. So, but it depends how much we are using. If you are taking in larger quantities, it might be harmful. So that's why we are following nanotechnology, where the quantity or the amount of neem oil will be very less.
So in the end, we have to see what are the pH regulations. Migration. So there might be something that we have to check. We want to go ahead.
Yes, definitely that's a good point. And being an engineer, so we are focusing on developing the technique and the ideas, and definitely we will move forward, and we will perform like we will collaborate with the governments, and we like focus on the rules and regulation as well. And we will see not only neem oil, like if there is something in the neem oil, there are different other natural fungicides which we can apply for that. If we are constrained with the neem oil, we can try something which is edible, like clove oil or any other things which are edible and good for health. We can go with that as well.
Have you examined the presence of your antibiotic, the farm or anything in any signs?
Like since we spray the moment, like because the internal we measured the physicochemical properties, the taste, the pH and other stuff, since it was not changing compared to the
My question is the different one. Whether it's a for like what it's for or there is a possibility. Let me around the finish. That like and also credit of the farm. Let me tell you.
so here I think the
Sorry, maybe continue discussion after this session. Sorry about that. So please, thanks for speaking again.
thank you so much everyone.
Move on to the next presentation. The topic is effects of drying medium on color. Some typical problems with spray drying green color powder stabilized and extract. So is yours.
Good afternoon, everyone. My name is Kampana from Kingswood University of Technology, Hungary. Today, I would like to share a topic about effect of light medium on color and some physical property of spectral green color powder from stabilized and extract. My presentation will cover on several points. So let's start with the first point. Chlorophyll are attractive pigment which abundantly found in nature. This pigment also possess inherent effects such as antimicrobial, antioxidant, for example. However, incorporating this pigment into food as a food colorant is very challenging, as this pigment is very unstable to high heat, low pH, light, and enzymes. Chlorophyll degradation is visually visible, observed by changing color from green to olive brown. Here are some examples of the degradation pathway of chlorophylls. The color change occurs mainly because of the loss of central magnesium atoms in chlorophyll structure. So it is a drawback of using these pigments as natural colorants. Interestingly, this pigment can be stabilized by metal complexation process. Normally, copper or zinc are used in the process of chlorophyll stabilization. Moreover, native and stabilized pigment are water insoluble. Water soluble pigment can be produced by introducing sodium to the pigments. The produced water soluble pigment is called sodium copper or zinc chlorophyllene. Although food colorants are commercially available in various forms, including liquid and gel, color powder is among the most popular form used to easy transportation, storage, and use. Color powder can be used after dry form or after reconstitution. Drying is an important process to be used natural colorants in powdery form. One of the more drying technique is spray drying. During spray drying process, the droplets are produced and solvent of water is evaporated within a few seconds, resulting in a product with acceptable quality. The most concern is that air is used as a drying medium. Oxygen in the air, however, can participate in oxidation reaction, which may lead in turn to adverse product quality change, including rancidity, discoloration, nutrient loss, among others. To alleviate the problems, an alternative drying medium called superheated steam, which contains negligible amounts of oxygen, ethylene glucose, and widely tested. Superheated steam dry product have noted to suffer less oxidation, induce quality degradation, and exhibit more porous structure. However, there are very limited study using food powder and food colorant powder using superheated steam spray drying. So the objective of this work is to produce a green food colorant powder while the use of superheated steam spray drying. Second, to evaluate liquid properties of produced powders. Third, to compare result with powder produced by hot air spray drying. Here are a brief flowchart to produce a green natural colorant powder. The green pigment was obtained from pandan leaf. Some processing steps are required, such as pigment stabilization, pigment extractions. So when removing by evaporations, saponification to make water soluble pigments, and spray drying by using
two different medium that are hot air and superheated steam. And after that, we obtain the green colorant powder. Hot air and superheated steam spray drying at 180 degrees Celsius were operated in the same spray dryer. Marco Richrin was used as the drying aids, and the total solid content was 30%. Color and some physical properties of spray dry color powder were evaluated. So here is the design discussion. So the first one is moisture content, water activity, and the percentage yields of the spray dry color samples. We see that there's no differences between percentage yield of the produced powders that which are around 48%. And we observe that the spin dry powder had higher moisture content and water activity than the hot air dry powders. Table 2 show about density, particle size, and size distribution of the spray dry powdery samples. We observe that the spin dry color powder had smaller particle size and broader particle size distribution. And this results lead to higher ball density of steam dry color powders. Here, this slide shows about the differences between hot air and superheated steam dry particle morphology at 500 times and 10,000 times magnification. Micrographs reveals that hot air dry were mostly large, gel balloon spherical shape and feature smoother surface as well as a broken shell. Steam dry color powder, on the other hand, was mostly small with highly wrinkled surface. This is probably because of some reasons. First, initial spray droplets under superheated steam is much smaller than that of hot air due to lower dynamic viscosity of superheated steam. Lower viscosity leads to feed solution easy to be torn apart, thus smaller initial droplet size. Second, steam spray dry powder appear as smaller particle with highly wrinkled surfaces. This is probably because superheated steam exhibited superior thermal property to air at the same temperature. This result more rapid moisture removal from the droplets. More rapid moisture removal resulted in third larger moisture gradient, hence larger moisture gradient induced stress that lead to more extensive deformation of the particles. Moreover, condensation that might have formed on the droplet surface during initial contact between atomic beam and superheated steam might have prevented transformation on the surface of such droplets that normally form in the case of hot air drying. Here is the result of hygroscopicity and reconstitution time of spray dry powder samples. We observe that there is no differences between hygroscopicity of the spray dry powder. They both were slightly hygroscopic. For the reconstitution time, we observe that the superheated steam spray dry powder had longer reconstitution time because during dehydration they were tightly packed together, leading to longer reconstitution time. Here is the result of colorless volumes of reconstituted solution. We observe that there's no differences between values of superheated steam and hot air spray dry color powders. So in conclusion, there were no differences between the powder color and percentage yield between the drying medium. However, hot air spray dry cooler had higher balanced moisture content and water activity. The produced particles were larger, smoother, with balloons spherical and more pH. Superheated steam, on the other hand, has smaller, highly wrinkled surface as well as longer reconstitution time. These findings suggest that superheated steam spray dry may not consistently yield favorable result for using relevant powder. So that's all for my presentation. Thank you for the attention.
Question. Speaker.
You explain the difference in the effects. Precipitated steam.
Which
What is the sense? What is that?
okay, for the reason why the superheated steam dry rainfall has smaller particle size, because the initial spray droplet of under superheated steam is much smaller than that's under the hot air drying. I would like to inform that during atomization, we use different compression medium. So in the hot air, we compress with hot air. In superheated steam, we compress with superheated steam at the same temperature. So we observe the viscosity of the feed solution. We observe that superheated steam has lower viscosity, so it might be torn apart easier than with the hot air. That's why it's much smaller in particle size.
Steam is 180 degrees in the atmospheric pressure.
In this,
What about the pressure?
we operate at the atmospheric pressure.
Any other question? Thank you.
Properties are not drastically different, and they are more or less same. What is the path implication? Which technique? There is incorporated not hot air.
As
In terms
the
of cost.
in terms of cost. In my opinions, for the laboratory scale, extreme superheated steam might much takes more cost than for industrial scale, we might can recover the steam for reuse, so it might be spent much lower than that of hot air. That's waste of the drying medium to the environment. In the superheated steam, we might recover some of steam if we have operate a fan design that can recycle the drying medium. So it might be much cheaper than that of hot air. The industrial scale.
Thank you. Did you consider the heat transfer? Heat transfer as heat transfer. Certainly, hot air versus steam. That might be better. Look at that. Thank you. Thank you very much.
All right, next presentation will be on a small scale oil and gas system. With the question that is it a viable rural entrepreneurship option in rural India? Yeah, that's the Where is Darula?
I can.
Yeah.
Good afternoon. Right. All the presentations that we have mostly on food. And then this presentation should be to another different place. This is not food or that we I mean, take consuming that is mostly waste or leftover part. That the critical case of protection of biogas. And then this work is by a abstract of it, around 10 years the research that is going on in India, one of the Indian university that is this university for which I'm studying from the university located in northeastern part of India. And here mostly the work is to understand the economy or business of biogas operation. Around 75 years running, this is going on here. This biogas, small scale household biogas systems in India. However, its growth is still limited. Why it's happening? Biogas is a technology which take care of the unused waste stream of material, having not any use, but enriched with nutrients and energy. It converts without much very sophisticated technological complexity. It has some biological complexity or biological considerations, but technologically very simple analog jar like this that I'm using can convert it into methane. And then methane is useful, it's a fuel gas, and also nutrients that also will be available to the farm. Despite of all readiness, despite of the different government approach as well as research institutions effort, its promotion is growth is very limited. Why is happening? There is a questions in this investigations we are presenting. This is mostly said that this technology, biogas technology, can address many of the issues concerning the division that you see in the development later now. That's urban is developing in different way. The rural area or maybe interior area is having a different development. The true sense, if you understand development, it has many implications, social, political, many reasons, including in India. So, I mean, bridging the gap between this development, cost or development, your scenarios to be reduced. And then entrepreneurship, that means business, can help you. Yeah, as some pictures are shown in the top row as well. It's very obvious. I think it's very and then how this division is going. And then one is this your cooking or you could say a job task, very essential task that is required in family systems, mostly like rural livelihood as well as urban livelihood. And the rural livelihood, though there are many approaches, still wood well is one of the key elements or key commodities that we consume. So it has issues. Issues one is the dredging of collection, second is deforestation, third is particular condition that create the health hazards. And then there are efforts earlier, there are say since 1946, the slides will tell that cleaner version is basically the decomposed biogas and also the LPG. Biogas, there are businesses with LPG. There is established business business not related to regions or nations, it's an international business, already established. But this small scale, a small bottles device, is that we call it LPG cylinder. A consumer can purchase it around 1,000 Indian rupees, and there are many components personally consumed. All that's doing there, which that business sense are not even or not done. Why it is not done? If we compare with this LPG that I will show you in the biogas, there are many drivers, even there are many sustainable development, the goal that every country has set by 2030. Biogas potentials to contribute is more than LPG. Still it is not that we are going to this time. This is business with the energy, with all energy sources, and then more emphasis is that renewable energy, and the biogas is a renewable energy. And then it has also potential. We just to give you the background and other things are known. Now, current era is that climate change, net zero emission target has made its importance more. But technologically or socially, this is not happening with reference to biogas. This is some of the analysis that you could see. We have analyzed it in comparing this biogas. Biogas is actually scale. Business and enterprises, obviously, it has a scale that we also discussed in earlier discussions of turmeric productions of turmeric in the technology sense. Obviously, it depends on the scale, at what scale we are technology serving. It is a home scale that is around 230 over around 1 kg of gas per day, or tons of gas per day, productions per day, or medium community scale, say several 100 kg per day. So that obviously, if you could say businesses, their scale is higher, but we are not comparing with the scale. So the larger scales, mostly because there are fund involvement, there are capital investment involvement, and there are many other complexities also. The main empowered farming community or rural community is not much empowered. You could see over business, bigger scales or larger scales. The smaller scales would have been better if we could technology could make it perfect to suit them, because there are many other small scale technologies that are going on. For example, the rural sectors, the family can do their earnings, the earned livelihoods with a few bullocks or few birds or few pigs or some hundreds of thousands of pieces with their vicinity or with their homesteads. And then it is equivalent to a biogas systems. These bullocks, cows or maybe poultry or maybe fishery or maybe pig also needs inputs. They input the biomass. They produces some sellable products, maybe milk, even cotton is also now sellable product. Then fishery fish, bigger meat, then poultry, eggs or less, and then ultimately there's a your lifestyle and then it goes. And it is a business, small scale business is going on. Biogas also requiring the input, that is again biomass, and then also produces biogas. There's a cleaning commercial sellable community, meter, heating value, your electricity, and then digested fertilizer, organic fertilizer, excellent organic fertilizers. Compared to original growth, it's still not happening. Why? This is some of the figures are given to understand this. Biogas system, as you said, Indian government, 1946 onwards. Before that also it was there, but formally whatever the things said still is going on, and there are different efforts of the government. Even financial involvement of this, different schemes, subsidy. And recently, government is going for large scale target of producing your vehicle, 12 vehicle, that is called compressed biogas. This is another model, as well as this other things what are there. Earlier things are that small scale biogas plants not only should fulfill the requirement well, it should also fulfill the requirement of these fertilizers. That's called manure management. But the downward trend over the years showing that your government has a target to establish the biogas or install the biogas. The target percentage is decreasing. And then also the installations, biogas users population is decreasing over the years. This is historical data available in the government sources. And then what we study that in our university we have a biogas we understood, can we make a business model? What the business is going to be? We need some residual stuff to operate it. We need some waste material which is otherwise going to sell, and we are making infrastructures. One important part we have realized, the digested part, the slurry part, we call it slurry or digested. It has a nutrients value, it has NPK and other organic materials. This is very, its care on these materials is or its management is very less or very limited in a traditional biogas system. And then the value is not realized. This is one. And the second, biogas we have found that this commercially, how can we use this material, and then how can you upgrade the raw biogas? Raw biogas contains moisture, raw biogas contains carbon dioxide. The flame that is produced by it is not acceptable or not comparable to this MPC. And that part small, that bigger scale, technology there, cleaning technology or scrubbing technology at small scale, market available technology. That's also one way of interest. But if you could see at institutional level, at the research level, perfectly provide and it's valuable solutions. We understood whether a small scale biogas plant of that kind can generate livelihood for people. We have also understood that whether biogas can also be a sellable commodity compared to an LPG. Our experiences would get and then it would produce livelihood. Now, one part is that we have to understand the slurry which is coming, which are leaking to the soil, so your soil, we have to understand its management. Separate it, liquid part, maybe in the vicinity or storing over here for spraying, solid part, again processing and how can you sell it, sellability to be under and to be done. Mostly you could understand there are some expenses, red or your bottom sales, and there are some revenues. Ideally, the users should understand some total revenue or your expenditures or your spending should be less than the revenue. Everything should be accounted. If accounting is done properly, it's a viable business. Mostly accounting is not done. One part would be it's considered in subsidized scheme, which is different governments of entity, not the individual center. That ownership is an issue. It's not only this, it provides the economical benefit. It's spent to contribute to sustainable development goal is more than the other goals or LPC or that we have investigated and we found. So it contributes to the sustainable development goal as well as it contributes to the economic development, social development goal. So biogas has an important your potential. We compare it with the dairy, small scale dairy systems, small scale poultry system, fishery systems, piggery systems, similar in a rural area, which are predominant, which is going on without any support, and we found that biogas that also equally compatible systems that would go provided business efficiency is understood, and then when we found that it's total net your different expenditures, then revenue that is generated per unit of expenditures, per unit of recurring expenditures, per unit of capital expenditures, if it is done, biogas stands with this. So it should go and it can go. These are some of the comparisons and some of the also net present value over the periods of the lifetime, biogas is comparable. That you see over here. It also contributes, as I said, many of the sustainable development goals that is required. Government has doing the assessment how we are contributing or reaching this development goals by 2030. Biogas is potential. So network of the biogas around 5 billion biogas plants are installed in rural areas, but many of them are not working due to small technical reasons that I said. If it is taken care, it would even good social solutions, sustainable solutions as well as economic solutions. These are some of the issues highlighted. small technological issues that can be taken care, then your commercializations, then fertilizers applications, because already government of India particularly saying that natural farming will be promoted. Natural farming without provisions of materials for it, particularly organic fertilizers, is not being successful. If we consider that whatever the waste material to be treated, and biogas is also then treatment plant for those waste material. By treating with that, biogas will be a byproduct, then its organic material is the main product. That way also it will contribute to this organic farming and natural farming as a good scope. And then farmers are empowered, not relying on the market for commercial fertilizers. He can take care of this own lab for this organic fertilizers for its own lab. Organic health, soil health will be much better than this other chemical fertilizers. Thank you.
Thank you. I have one quick question.
Well, it is interesting now, but biogas has been around in India for quite a long period of time. Has served their own development. And I see that the trend is changing. That's what I gather. So now that is because of now LPG, of course, is so much easier, and so people becoming much more converted even in the world. So integrating of these things would be a big step forward in terms of that. But with there a clear pathway established with the government intervention, usually in the state driven thing. That I'm 7 years in Karnataka, for example, and there the popularization of that has happened. So when I look at those things, yes, this needs to be done. So what is your prediction in the future?
Yeah, but it's found that government intervention is okay. Ideally, it's very perfect. However, sometimes the agents or the systems works differently. So if it is better free from the government interventions, rather other things are facilitated. For example, there may be very critically required sensors for biogas operation. Because biogas helps, particularly it's about your microwave health during fluctuating temperature conditions are not known to users. If the users know it, and accordingly he can you are control the feeling. If those things, those small tools and technologies are made available by the government interventions, as an other technology, as a smartphone people are using, or you are having any government interventions, it's growing at exponential level, it will soon. If we have a mechanism, for example, I am saying there are renewable energy technologies all over the villages, and they are provided some regulations if they increase the number of installations. So then person's interest is to increase the number of installations rather than taking this operation of install person facilities operations or functions. So there are hurdles with this type of machineries, government machineries. So what is intended over here is that some of the business government is not helping. Maybe sometimes soft loans, some loans are given, that loans and other things will be given, then government interventions or government schemes may not be required. Let it be a perfect technology that people will do it.
Thank you very much.
Thank you.
So we now move to the final paper of this afternoon. So I invite the next speaker. The title of this paper is Biological Compounds, Color and Antioxidant Activity for Better Lens from Dragon Fruit Fields. Comparison between conventional and ultrasound assisted extraction.
Good afternoon, everyone. My name is Jasmine Mamo. My topic for the presentation today is bioactive compounds, color, and antioxidant activities of betalains from dragon fruit peels. Comparison between conventional and other cell-assisted extraction methods. So today I'll focus on a few key points. To begin with, I'll provide a brief introduction of why dragon fruit peels and how to extract those bioactive compounds. And then we'll move to methodology, results, and discussion, and finally conclusions. So first, why dragon fruit? So dragon fruit, also known as pitaya, and it's several different cactus species, and it's originates from southern of Mexico and Pacific coast of Guatemala and El Salvador, and also cultivated across Southeast Asia. And the dragon fruit peel market is about 526 million USD by 2024, and the compound average growth rate of 6.9% until 2034. And in Thailand, dragon fruit can cultivate all over the regions. And for the Department of Agriculture in Thailand reported that up to 21,000 acres of cultivate with a yield of up to 25,000 tons. So we can see that dragon fruit market in Thailand also is really huge. So from dragon fruit, we have about 30% of dragon fruit peels, which is usually just discarded as a waste or made it as fertilizer. So, but a lot of reports that can found that these peels have a lot of compounds. For example, pectin, beta-theanine, which is a really good source of red colorants, and have dietary fiber, phenolic compound, bioactive compound, include vitamins and include acids that has been associated with this reduce of diabetes, dyslipidemia, cancer, metabolic syndrome, and also cardiovascular disease. So now we know why dragon fruit and why dragon fruit peel. So how we extract those bioactive compounds from those dragon fruit peels. So now we can extract either with conventional method and non-conventional method. Conventional methods such as chocolate, orbital stacking, or maceration will be simple and low cost, but it requires long extraction time and also low use, because those maceration and shaping will need at least 2 to 24 hours. And chocolate have requires some heat, so will loss of those bioactive compounds. And for non-conventional method like microwave-assisted extraction, outside-assisted extraction, enzyme-assisted extraction, and high hydrolysis pressure can overcome these problems. And those enzymes and high hydrolytic pressure require a really expensive equipment. So this microwave and ultrasound is introduced as a low cost, but microwave requires some heat. Those heat can reduce those bioactive compounds. So in this study, we will use ultrasound-assisted extraction and maceration compare. So it's lead to the objective of this study, which is to conduct a comparative analysis between ultrasounds and maceration. Maceration at 25 degrees C for 2 hours, and ultrasound at we will find the best condition, and then we will compare beta-cellulose content, color profile, and also antioxidant activities. Next will be the methodology to use for this study. This is overall framework for this study. First, we begin with dragon fruit peel, and then make it to dragon fruit peel powder. For the process of this, I will explain for the next slide. And after that, we will extract those bioactive compounds either with conventional extraction and UAE, which is ultrasound assisted extraction. For the conventional, we use maceration at solid liquid ratio of 160 for 2 hours. And UAE, we use several treatment from solid liquid ratio from 1 to 60 to 100, and other altitude at 20 to 60% at 20 kilohertz, and extraction time from 2, 4, and 6 minutes. And this condition is from our preliminary experiment. And then after that, we compare beta-catenin, beta-catenin content and color, and we will find the best condition for UAE. And then we will compare total phenolic compound antioxidant activity from 2 methods between UAE and conventional. And for the extractions, as I mentioned earlier, that we began with the dragon fruit peel, and then we chopping, drying at 40 degrees C for until constant temperature, which is about 24 hours, and final moisture content about 8%, and then drying, and then grading and sieve through 500 micrometer sieve, and then we will get dragon fruit peel, and we store it in the dark in the densicator. After that, we use this dragon fruit peel powder to extract either with conventional and non-conventional, and then centrifuge and immediate analysis. For the UAE, we will have 5 treatments, UAE 1 to UAE 5, which you can see in this table. Next, for results and discussion. Here from this table, we can see that for conventional method, beta-catenin content is about 17 milligram per liter, and for beta-catenin is about 8 milligram per liter. From UAE is vary from 8 to 15 milligram per liter for beta-catenin, and also for beta-catenin is 3 to 7. So we can see that at UAE 3, with the conventional method, beta-catenin and beta-catenin content is comparable with no significant difference. This can be due to the calculation in ultrasounds, so it will possibly disturb those cell wall and then facilitate the release of intercellular of beta-catenin. So for the color, lightness and redness, because we want to make red colorant, natural colorants, which is beta-catenin with red color. So we can see here in this table, also for the UAE3, which is a power and liquid ratio of 1 to 60, and extraction amplitude is 60 degrees and time only for 2 minutes. It's no significant difference with conventional method, which is used for 2 hours. So now from the previous results and these results, we can find the best condition for UAE extraction, which is powder water ratio of 160, ultrasound amplitude at 60%, and ultrasound time is 2% at 2 minutes. So after that, we compare those best condition of UAE and with conventional. So we can see in these figures that total phenolic compounds, DPPH, antioxidant, and also PrEP, it's no significant difference between those UAE at 2 minutes and conventional maceration at 2 hours. So it leads to the conclusion of this study, which is UAE could significantly reduce the extraction time compared to maceration, and then the best condition for UAE is powder water ratio of 1 to 60, ultrasound amplitude of 60%, and extraction time only 2 minutes. And from TPC and from antioxidant activities results, you can see that UAE at the best condition results in the comparable quality that obtained by conventional extraction, which require much longer time, which is 2 minutes and 2 hours. And this will be all my presentation. Thank you.
Thank you. Floor is open for questions. So what do you think of dragon fruit peels making an impact from the economic perspective?
For now, because we doing it large scale, drying we use hot air dry from dragon fruit peels, and this dragon fruit peel is a waste from the resale peel from our university. So I think for now it's can be economically like make it waste to one whole and say. But in the future probably we will do like deal with factory something like that, so will be really make economically.
Thank you. Thank you very much. So there are a couple more things to do as far as the closing of the session is concerned. However, I would like to make certain comments. You know, a conference is always a place where you change. So since morning, what have we learned? So in the morning, I think farmer-centered things, whatever we do so that it benefits that. I think one key message that I learned, besides of course sustainability. Now I see that you all gave a nice presentation. Then the conference is around sustainability, very challenges. So whatever you do in research, please consider UN 17 sustainable goals. In that, I'm sure more than one applies to your research. So certainly, beside the science and technology, keep this sustainability goal in perspective and make an effort to connect them up. So that's how, just like what we learned in the morning for the farmers, now similarly the sustainability, any research paper that you do, bring that to your overall study. That you will be helping other researchers, at the same time helping yourself to consolidate your thoughts as you move forward in your life. So that's one message I thought I should bring. So thank you for all of your efforts to bring the information to focus here. And certainly I thank my co-chair, Professor Salman, be out. As you can see, that to bring this session together, we need a lot of help. I have many people contributing to this from that angle. I take this moment to thank them all for this. Let's keep them all at it. With that, I think there are a couple of things that they want to do. So
It's Professor Ganapati. Thanks so much for uh, Rahul.
Yeah.
Last one is, yeah. So,
And yeah, please, thank you very much. So you want to say?
hope you enjoyed the lecture. Thanks again, and have a nice section and see. Okay.
So, would like to present, cooking appreciation.
Oh,
So we are inviting Mr. Wilborn, the planned vice president of TSAE to present cooking appreciation to the session.
Thank you.
Thank you everyone for participating in this webinar. It's great.
Oh, I've been, oh, it's really,